Check, check. Hello. Why isn't it there? Okay. There we go. Hello. Check, check. Come on. Why is that? Okay. But check, 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 check. Okay. Hello, is anybody there in the live chat? Live chat. Hello? Can you see me? Okay. Why isn't it? It's there. Okay. Alrighty. Can you check in through the chat or send me an email if you see me? I'm not seeing anybody in the chat. Check, check. Check. I'll keep it here. All right. We'll see if other people show up. Please either email me your questions or please post them in the live chat. Today I'd like to go over the molarity worksheet and the solution stoichiometry problem that you had, and any questions you have with those types of calculations, those molarity calculations, or the solution stoich calculation. Okay, so please feel free to email me your questions or post them in the live chat. Okay. Does anyone have any questions? Okay, so again, the first couple things, the things I want to go over are the molarity worksheet, which was on the second page of the molarity notes handout. Okay, so these calculations here, or the solution stoich practice here. Let me know if you have any questions at all with any of those, any ones you'd like to go over. Also today I posted a practice test for Unit 6. So I urge you to go through that practice test today and tomorrow. Tomorrow I'll post the key. So sometime tomorrow after you finish the practice test, please go over the key, look it over, and then I'll be on again on Wednesday to chat with you again on any questions you have on the practice test. Okay, and kind of just understanding how things are going to go. The county is now going to be implementing in the next couple days. We're going to use this program called Zoom. Okay, this website, I think it's called Zoom. And it's a place that we can have live streams and meetings and virtual meetings. And so that's what we're going to be doing. For the next, so we probably won't be live streaming on YouTube after that gets pushed out. So once the county gets that all set up for the teachers, They're going to set it up for you guys, and you'll be notified via email in the next couple days about starting a Zoom account. And then instead of doing my live streams on YouTube, I'll probably be meeting you guys in the Zoom environment, which is again a virtual online meeting place. We're still going to be moving forward and learning new content. How I will grade and test you, we haven't been told how to do that yet, or how we're going to do that yet. But that's what we're going to be discussing in the next couple of days. And so I know they said by March 27th, you guys will know more stuff, and you will. But just understand, like, so the Unit 6 practice tests. This is just a practice test. It's not a grade, but they're concepts you are going to be responsible for, and so. You might want to stay on top of it, because when we do get back, if we do get back, whatever, it's still content that you will be responsible for. And a lot of this content is content that's going to be necessary for you to know at the next level of chemistry, whether it's AP or if you take chemistry in college. So, just try to stay on top of things. Eventually, you'll be hearing from all your teachers, if you haven't done so, if you haven't heard from them yet, about the Zoom conferencing. And we're probably going to be moving on with actual learning new material in the next few days. So just be on the lookout for that stuff. But are there any questions? I got a few people watching. But no one's asked a question yet, and I'd like to answer your questions if you have them. If you don't, then I guess we don't need to be here. But you can either send me an email or ask a question in the live chat, or just say hi in the live chat. Let me make sure. Hopefully the live chat's working. I posted a couple things. Can you see my email address and things like that? Like, post in the live chat if you hear me, or if you have a question. Or send me an email. Okay. Any questions? What did I just do? Huh. Hi. Do you have any questions, Zohal? Thanks for saying hi. Anybody else have questions? Okay. If you don't have questions, I'll go through a couple of the highlights from the practice worksheets, and maybe that'll spark some questions. And then last example on solution stoic notes. Okay. Good call. Solution stoic notes. Let's just make sure, is this the right question? June, can you let me know what mass of lead 2 chloride will precipitate? Is that the question you're talking about? I just want to confirm. June, is that the question you're talking about? Is that the question? Or was it? Sorry, it was this question. Sorry. This question. The student requires 45 grams of silver chloride. Is that one? That's the one you're talking about? Sorry about that. Messed that one up. Oh, okay. Okay. All right, let's go over it. All right, so All right, so one way you could get silver chloride if you didn't have solid silver chloride available to you, but you needed it. If you had silver nitrate and you had sodium chloride, you could mix both of those in water, so you could get two solutions of aqueous sodium chloride and aqueous silver nitrate, right? And knowing that when we mix those two solutions, silver chloride the silver ions and the chloride ions will come in contact with each other, form a compound that's not very soluble, and precipitate out of solution. And so this is saying a student requires 45 grams of silver chloride, and they want to know what volume of a 0.5 molar solution of silver nitrate should they add to a solution that contains excess sodium chloride. So if we looked at like the net ionic equation, we just have silver plus ions plus chloride ions are forming silver chloride solid, right? So we got silver ions and chloride ions, they're forming solid silver chloride. So we want to know how much silver solution do we need to add, right? How much of the silver nitrate solution, which is our source of silver, how much of that do we need to add to an excess of chloride to get 45 grams of silver chloride, okay? So again, it's just stoichiometry. So if we follow our steps on what to do, the first step is take what you're given and convert it to moles. Well, we have 45 grams of silver chloride. We need to know how many moles that is. So that's this first step, right? Our second step after we balance the equation, right? So our second step, take our grams of silver chloride, convert it to moles. Now, that's how many moles of silver chloride we need, and our source of silver chloride is going to come from the sodium chloride solution, which we have an excess of, so we don't have to worry about that, and the silver nitrate solution. So we want to know how much of the silver nitrate solution we need. So that's why we're going to then multiply by 1 over 1. It's 1 mole of silver nitrate for every 1 mole of silver chloride. That'll give us how many moles of silver nitrate, okay? So the last step for this question is to take what we're given, so we have moles of silver nitrate that we need, and convert to desired units, okay? Well, our desired units is volume of an aqueous solution. So I know how many moles of silver I need, but I need to know what volume of this solution do I need to get that many moles of silver, right? That's really what the question's asking. What volume of this solution? Well, we were given the molarity. What was the molarity? The molarity was 0.5. So we have 0.50 moles of silver nitrate for every 1 liter. Right, that's what molarity is. It's 0.5 moles per liter of solution, and we want to know how many liters of the solution we need to get X number of moles, whatever we just sound for. So if we take our X moles of silver nitrate and we multiply by the or we divide by the molarity. If I insert an equation, so the way to interpret the molarity is to say 1 liter for every 0.50 moles. Oops. Right? So what we're doing is taking our moles of silver nitrate and dividing by the molarity. And if you take moles and divide it by molarity, that gives you how many liters of solution we have, right? So that conversion factor here, 1 liter for every 0.5 moles, comes from this molarity measurement, right? So molarity can be used as a conversion to go from moles to liters, or it could be a conversion to go from liters to moles. In this case, we're using it as a conversion to go from moles of silver nitrate to liters of silver nitrate solution. So we're dividing by the molarity, moles cancel out, and that gives us our liters. And then I just converted it to milliliters just in case. All right. Does that make sense? Okay. Hopefully that answers your question. Let me go back. Okay. So did that answer your question, June? Does it make more sense now? Did that illustrate it a little bit more? Just want to make sure we get that, okay? It's just, so it's really, essentially what we're doing is, let me get those notes. You know, so when are we going to use molarity in stoichiometry? We're either going to use it in step 2 of our stoichiometry or step 4, where we're taking a measurement like molarity, we're taking that and we're making it into either that conversion factor here to go from liters to moles. So if I multiply by that, liters will cancel out and give me moles. Or using it this way to go from moles of something to the volume of the solution you need to get that many moles, right? And that's what we're doing here. So we can take a measurement like molarity and make it into 2 conversion factors, just like how we used to take a measurement like density, which is like grams per liter or grams per milliliter, and convert it into 2 conversion factors, right? So density is our conversion factor to go from volume to grams or grams to volume. Molarity is our conversion factor to go from liters to moles or moles to liters, right? And so we took that, you can, from that measurement here, you can get those 2 interpretations of that measurement and use one to convert to desired units. And that's what we did here. We took that measurement and we got this conversion factor from it, right? 0.5 moles of silver nitrate molar silver nitrate means 0.5 moles of silver nitrate for every 1 liter, or 1 liter for every 0.5 moles. Okay. Okay. Are there any other questions? Okay, so you did the notes. Are there questions on the molarity worksheet? Okay. Again, I posted the key, the molarity worksheet, or the solution stoic challenge problem. If you get those, then you should be good with molarity for right now. And hopefully, you know, if we get back to school, when we get back to school, we'll be able to work with molarity a little bit more. Because it's a very important measurement to be able to work with at the next level. Okay, so if you're planning on taking AP or taking chemistry in college at some point, molarity is a very important unit to be able to use in these types of calculations. Okay. Any other questions? Can you go over number 7 on molarity? Okay, number 7. So let's. Okay, number 7 on the molarity worksheet. Let's do that. Okay. All right, so here's number 7 on the molarity worksheet, okay? So this is important to know, and I'm going to try to illustrate it to you a little bit. It's really understanding what happens when a salt dissolves in water, right? So what we really need to understand is when an ionic compound or a salt dissolves in water, right? It dissociates. It breaks up into the ions that make up one formula unit of the compound. So you think of the word, so molecule and the word formula unit are the same thing. So like, think about, so 1 unit of calcium chloride has 1 calcium ion and 2 chloride ions, right? So really what we need to understand is when I say I have a solution of any salt, of any ionic compound, understand that means the ions have separated and are surrounded by water molecules. That's what an aqueous solution is, right? So when I say you have an aqueous solution of an ionic compound, so understand, when calcium chloride dissolves, it's not calcium chloride solid anymore, right? It's calcium chloride aqueous, okay? But understand what aqueous means. What aqueous means for an ionic compound is the ions in one formula unit of the compound have separated. So when I say I have an aqueous solution of calcium chloride, I really have calcium 2 plus ions by themselves, and I have a chloride ion by itself, and I have another chloride ion by itself, right? So really, you have this ion surrounded by water molecules, you have that ion surrounded by water molecules, and you have that ion surrounded by water molecules. They're not together in the solid structure anymore. Okay, that's really how you have to think about it. So to simplify it, right, we could say calcium chloride, solid, when dissolved in water in a solution, it's really this. It's calcium 2 plus aqueous plus 2 chloride ions aqueous, right? So that's really what we have. We don't have Cl2, we have 2 chloride ions, right? We don't have calcium chloride together. We have calcium ions and 2 chloride ions that are separated. So that's the solution form of it. That's an aqueous solution. This is the solid form of the compound. Yeah, the ions are together, but in the aqueous system, the ions are separated. Okay, so what we need to understand is for every 1 mole of this compound, for every 1 mole of CaCl2 that dissolves, you get 2 moles of chloride ions. All right, does that make sense? Now, where did we get that 2 from? Well, it's the subscript of the chloride and the sodium chloride. So if you have a solution of calcium chloride, if you have a 1 molar solution, that means 1 mole of calcium chloride for every 1 liter, right? That means you would have 1 mole of calcium ions, but you would have 2 moles of chloride ions, and you would have a total of 3 moles of ions. Okay, does that make sense? So if we go back to the worksheet, okay, it says how many chloride ions, so I want to know just chloride ions, are in this volume, 7.5 liters of a 0.5 molar solution of calcium chloride. So let's understand, this would be stoichiometry, right? This is composition stoichiometry, where you use the chemical formula to get your ratio. It's not reaction stoich. You don't have a reaction, but you could use this reaction, right? You could use this, right? You could say the mole ratio is 2 moles of this chloride for every 1 mole of calcium chloride, right? But where do we get that number 2? We get it from the subscript. Okay, so it's stoichiometry. Let's follow our steps, right? Step 1, know your recipe. Well, our recipe is the formula of the compound. In this case, calcium chloride. It was given to us. And the very important part of that formula is that the subscript of chloride is 2. There's 2 chloride ions for every 1 calcium chloride formula unit. Okay? So, step 2, take what we're given and convert it to moles. 7.5 liters times the molarity gives you moles, right? Liters times molarity gives you moles, right? I'm taking this measurement here, I'm taking that measurement here, and I'm interpreting it this way, right? That's what 0.5 molar means. It means 0.5 moles of that compound for every 1 liter of solution. So liters times molarity gives us moles. Okay, now that's moles of calcium chloride, but I had to recognize that there's 2 moles of chloride for every 1 mole of calcium chloride, right? That's our mole ratio step. That cancels out moles of calcium chloride and gives me moles of just chloride. But it asks for total ions. That's moles of ions, so I have to multiply by Avogadro's number to get how many total chloride ions I have. Okay, so hopefully that makes more sense because we really have to understand how ionic compounds, what ionic compounds really are in an aqueous solution. An ionic compound is a solid structure, is repeating units of cation, anion, cation, anion. They're right next to each other. But in an aqueous solution, those ions are now separated and they're surrounded by water molecules. Okay. All right. So I hope that helped. Okay. Any other questions? Any other questions? And again, feel free to email if you have it. Yep, no problem. So, Hall, did that answer your question? Like, do you feel like you get it now? I was thinking about pulling up some like diagrams, but I might do that later. But it's just really understanding how the salt dissociates. You know, that's really what it comes down to. You know, an aqueous solution of salt is just the ions are separated. Okay, and how do the ions separate? Well, they separate based on the number of their subscript in a formula unit. So like, you know, it's just, you know, if I say I have an aqueous solution of you know, let's say I have an aqueous solution of ammonium phosphate. You know, it's really important to understand, like if I say I have an aqueous solution of this compound, it's important to realize, well, that means I really what I have are 3 ammonium ions floating around and 1 plus 1 phosphate ion floating around, right? So let me scroll down here. So and like we don't show the water, but it's understood that aqueous means surrounded by water. But really what's happening is like when I say if I have ammonium phosphate solid, yeah, it's a bunch of ammonium ions surrounded by phosphate ions, surrounded by ammonium ions, surrounded by phosphate ions in this solid structure where they're right next to each other. But in the aqueous sense of it, it's really for every one formula unit of these that I have in an aqueous solution, I really have 3 ammonium ions surrounded by water, and I have 1 phosphate ion surrounded by water, right? Okay. So that's really just how to, okay. All right, any other questions? Did we get the challenge problem? Or any other questions? Any other questions with the molarity worksheet before we move to the challenge problem? Okay. All right. I guess let's look at the challenge problem. And I think, you know, if you really understand, whoops, that's the wrong one. If you really understand the last question, you're in really good shape. But really, it's you know, so A is really what you need at this level of chemistry. Like if you understand how to do A, then you're great at this level. But if you really want to really understand what's going on, then or demonstrate that you really understand what's going on, then you really need to know how to do B in C. Okay, so let me just walk you through it. Okay, so real quick, so A is just, you know, so this is limiting reactant stoic, but to kind of add to it, it's solution stoic. Okay, so right, it's limiting reactant because I'm given specific amounts of silver nitrate and sodium chloride, right? So we have this this reaction going on again. We have silver nitrate, sodium chloride. It produces silver chloride as a precipitate, okay? So the first thing is we'd have to, you kind of know our solubility rules in order to know that silver chloride would be the precipitate, right? And if we don't have those memorized, it's something that we'd have to look up to know which ones are precipitate. Because I need to know the precipitate, because if I'm asked for the mass of the precipitate, I'm going to need to, be able to calculate its molar mass, okay? So it's limiting reactant, so you got to take each amount, do the stoichiometry with it, and figure out which one produces the least amount. So what we did here, this first calculation here, is if all the silver nitrate precipitates, or if all the silver precipitates, essentially, not the nitrate, but if all the silver precipitates, this is how many grams of silver chloride I could get. But I have to check and see if I have enough chloride, right? And so this is the calculation with the amount of sodium chloride. If that's how much sodium chloride reacts, then I should get 28.7 grams. Okay, so the answer is 6.45 grams because I don't have enough silver to get 28.7 grams, right? I'm going to run out of silver and I'm going to have excess chloride, okay? Are there any questions with part A, the way that's set up? Now, I'm using a slightly different molar mass of silver chloride in this calculation than other because I used a different periodic table when I made this key. And the periodic table I used had a different mass, I think for silver, slightly different than the one that you guys use. So if your molar mass is slightly different, don't worry about it. It's just I used a different periodic table. Okay. So are there any questions with that setup? It's just again, it's just limiting reactant stoic. We already know how to do it. It's just with solutions now that we kind of understand that measurement of molarity a little bit better. Okay. All right. So let's talk about calculating the new molarity of the ions that remain. Okay, so it's hard for me to illustrate this. Let's see. Let me see if I have a good one here. Let me see if I have a good picture of this. The hand warmer lab? I think maybe. No, shoot. Okay. Hold on, sorry. There's a diagram that shoot. Okay, it's not there. All right. Well, let me just try to spell it out here. Okay, so so we got silver ions, we got nitrate ions, we got chloride ions, and we got sodium ions, right? They're all floating around, right? They're all floating around. They're all separated and surrounded by water molecules. But what happens is the silver ions plus the chloride ions precipitate out a solution. They take each other out, right? But what ends up happening is that forms solid, and so that solid falls down to the bottom of your beaker, okay? But any ions that don't if silver, once you run out of silver, right? Now, there's nothing in the solution that can take the chloride out of solution. So what's still in solution? Well, I still have sodium or nitrate ions, I still have chloride ions, and I still have sodium ions. I don't have any more silver ions because all the silver ions precipitated out of solution. But I still have aqueous nitrate, I still have aqueous chloride, and I still have aqueous sodium, okay? So the deal is, I have those ions, they're still dissolved in solution, so they still have this measurement of molarity, right? Moles per liter, right? So I want to know the new molarity of, is it nitrate in the challenge problem? Oh, sodium ions. Okay, so I want to know the new nitrate, or the new molarity of sodium ions, right? So well, what do I need to calculate that? Okay, molarity of sodium ions would equal moles of sodium ions for every liter, right? Per liter, right? So what we have to understand is none of the sodium reacted, right? Sodium was a spectator ion, right? It didn't precipitate. So the amount of sodium dissolved before the reaction is the amount of sodium that's dissolved after the reaction. So moles of sodium didn't change. But what did change? When I mixed the two solutions together, I got a new volume. The volume's different. It's not the same amount of liters, right? The initial amount of sodium was 4 molar, but that was when it was in 50 milliliters. So that would be 4 moles for every 0.050 liters, right? But now I have that same number of moles of sodium, but now in a larger volume, right? The volume is now 50 milliliters plus 15 milliliters, right? So understanding when I mix the two solutions, my new volume is the sum of the two volumes. So in this case, it was 65 milliliters, which is 0.065 liters. So what do I need to do? I need to take the moles of sodium that are in the solution and divide it by that volume. Where did I get that volume? It's my new volume. Okay, so and moles divided by liters is what molarity is, right? So that's this calculation. So how did I figure out how many moles of sodium I started with? Well, let's take your source of sodium, which was the sodium chloride. We had 50 milliliters, so that's 0.05 liters, times the molarity. That gives me moles of sodium chloride. And it's a 1-to-1 ratio. There's 1 mole of sodium, right? The subscript for sodium is 1 for every 1 mole of sodium chloride. So that gives me moles of sodium. And now the key is, I understand that sodium was a spectator ion, which means it didn't react in the reaction. So that means all the moles I started with equal all the moles I finished with. So all I have to do is take that number of moles and divide it by the new volume. I found the new volume by taking the sum of the two volumes I added together, and that gives me my new molarity. Okay? All right. Those of you that are watching, does that make sense? Do you get part B? Just give me a quick yes or no if you get part B. Like if you get part B, you're good, and then we'll talk part C. Okay? Just want to see. Are there any questions with part B? Anything at all with part B that I need to get into here a little bit more? All right, so I'll take that as a yes, and we'll just talk about part C real quick. All right, so part C, now we're asked to find the concentration of the chloride. Now, chloride's a little bit different. We can't do this same calculation that we did for sodium, because the difference between sodium and chloride in this question is chloride is not a spectator ion anymore. Okay, sodium was a spectator ion. So what does that really mean? It means the moles of sodium that you started with equals the moles of sodium that were dissolved when you finish. However, some of the chloride is no longer in the solution anymore, right? Some of the chloride reacted with the silver and precipitated out of the solution, and it's no longer part of the solution, okay? So to find the molarity of chloride, you need the moles of chloride that are left in solution. So the moles of chloride that didn't dissolve, or sorry, didn't precipitate. You need to know the moles of chloride that didn't precipitate and divide by the volume. Well, the volume's still the same. The volume's still 0.065 liters. So I'm still, at the end, I'm going to divide by, I'm going to take my moles of chloride that are dissolved and divide it by 0.065 liters. But I need to calculate how many moles of chloride that are still dissolved, right? So this is, you got to know how many moles of chloride you started with. You have to subtract the moles of chloride that precipitated out of solution, and that's the moles that are still left over, and then you divide by the new volume, which again is 0.065 liters, okay? So I have that set up here. Let me see if I can rotate this, rotate, okay? So the first thing I need to do is figure out how many moles of chloride I started with. So again, my source of chloride was the sodium chloride. So I take 0.05 liters times the 4 moles per liter, that's the molarity, times 1 to 1, and that would give me moles of chloride. So that's the moles of chloride I started with. Now I have to do stoichiometry to figure out how many moles precipitated. So what I did was I took my amount of precipitate and figured out how much chloride was in there in terms of moles, right? So I take my 6.45 grams of silver chloride, divide it by the molar mass. That gives me moles of silver chloride. Then times 1 over 1 will cancel out moles of silver chloride and give me moles of chloride. So this is how many moles I started with, dissolved, right? 0.2 moles chloride dissolved. This is how many moles precipitated out. So I subtract, and that's how many moles of chloride that are still in solution. But the question doesn't want moles of chloride, it wants the molarity. So how do I get molarity? I take the moles and I divide by the volume. And again, that point, notice that 0.065 liters comes there at the end. So all I do is take my moles that are still dissolved, divide it by the volume, and then I get my new molarity of chloride ions, okay, in the resulting solution. Okay, so hopefully you get that and you don't find it that challenging, and yeah, that's it. So I guess, are there any other questions before I let you go? You have the practice test you can work on. All right, try to stay on top of things. You know, at some point in the next, few days, we're going to understand how long we're going to be missing school. Grade-wise, what do I need to do? And I'm going to be able to actually start assigning work for grades, and we're going to figure this out. So, try to keep on top of it. You're ahead of the game. There's not that many people here. There's only 4 of you out of, 90 students. So, I appreciate you being here, and try to stay on top of your work. I'll be on Wednesday again to go over any questions on the practice test. Okay, so you have the practice test, do the practice test. I'll post the key tomorrow, and then I'll check yourself tomorrow, and then with the key, and then on Wednesday I'll be on again to go over any questions you have on the practice test. Okay, and again, also be on the lookout for emails and stuff, because tomorrow I'm meeting with the rest of the science teachers, and we're talking about the new program we're going to use. So we might not be using YouTube's live stream. I might be using this thing called Zoom. And so you might get an email from the county talking about Zoom. So until you get notified that you have to use Zoom, I'm going to use the YouTube live stream. But once you get the notification that you have to use this program called Zoom to meet with your teachers online, then I'll start using that instead of the YouTube live stream stuff. And then, so be on the lookout for that. And if you're working on review stuff, quiz corrections, so eventually you can do a quiz retake. Keep doing those. Maybe if we're not coming back to school, if we're coming back to school later than sooner, then as soon as I'm allowed to assign stuff that's graded, I might be able to assign you, you know, a retake, like a quiz retake online. Like you know what I mean? But so make sure you have your corrections done, and you get, and if you have any questions about any quiz corrections you're doing or anything, you know, feel free to email me and let me know. Okay. But just be on the lookout for the stuff because it's definitely coming down. We have our department meetings tomorrow virtually to talk about the Zoom stuff, and I know the county's going to push it in the next couple days or so, at least by Friday, because you know that's the directive you have. So I think after Friday we're going to be able to start assigning some stuff, and because you've been kind of keeping on top of that, you're going to be ahead of the game of everyone else who's treated this like a 2-week vacation. Okay. So again, let me know if you have any questions. Send me an email. Thanks for coming and do the practice test. Okay. I'll post the key tomorrow. All right. Thanks. Have a good day.